Hey everybody, Trey here. Welcome back to another forecast discussion. The SPC has now upgraded to a rare moderate risk level 4 out of 5 for parts of the mid-Atlantic into the East Coast states. Moderate risk extends from eastern Kentucky, far northeast Tennessee, up to the northeast through eastern West Virginia, the western half of Virginia up into the Maryland and far southern Pennsylvania areas. Places like Baltimore, Washington, D.C., down toward Roanoke, Virginia, under the gun for the greatest threat for severe weather today. Large enhanced and slight risk areas surround it. The slight risk extends all the way up from the New York-Canada border down to the deep south, Alabama, Georgia, South Carolina. So very potent severe weather threat, not something we often see during this part of the summer, but it is certainly a potent setup that will foster the threat for significant severe weather today. All hazards are on the table. Tornado threat is now at a 10% in the yellow area there, so from eastern Kentucky, far western Virginia up to the northeast through the eastern half of West Virginia into the Maryland and southern Pennsylvania area, with a damaging wind threat producing the upgrade to a moderate risk. They have a 45% hatched area within that moderate risk zone. So the significant severe wind gust threat is on the higher side today, and we'll tell you why here in just a second. Large hail is going to be a threat as well, but again, the main threat is going to be damaging winds and a few tornadoes. Now we're going to be focusing on this moderate risk area in this particular video. I do want to mention that there is a slight risk out to the west for parts of Colorado, Kansas, into Nebraska, with an all hazards threat as well. Tornado threat is now at a 5% for that Kansas, Colorado, Nebraska triple point area there. Damaging winds and significant large hail a threat as well, with supercells in that regime. But as we said, we're going to be focusing on the main threat today in this video, which is that moderate risk area out in the East Coast. So without further ado, let's go ahead and get started. We'll start out with our water vapor satellite imagery like we always do. And very noticeable right off the bat is this big old swirl that is here across the southern Great Lakes into the Midwest. This is our big trough that started up here in the northern plains a couple of days ago and has slowly meandered to the east-southeast, has had a positive tilt to it for the last couple of days and is now starting to wind up a little bit more and take on more of a neutral to slightly negative tilt. We'll show you some of the data here, some of the upper air maps and some of the model data here in a second to illustrate that process. We also have an area of thunderstorms ongoing across Oklahoma into Arkansas in a warm advection regime associated with a second speed max. The main speed max is going to be up here into the mid-Atlantic states, with a secondary speed max back here approaching the southeast states. That is that second speed max helping to fuel this area of storms here, along with some warm advection right now. That will foster the development of severe thunderstorms in the southern portion of the target, while this main trough up here will be our main main driver for severe weather in the moderate risk area today. Let's show you what's going on right now. This is our current radar, and one feature you see right now is this swirl up here in eastern Ohio. This is an MCV. We've talked about MCVs the last couple of days. An MCV is basically just an area of swirl that is left behind by a decaying MCS. MCV stands for mesoscale convective vortex, and this can act like a sort of surface low and extend into the upper levels as well by enhancing the deep layer flow and helping to back those low-level winds out ahead of it, and can foster a tornado threat. It's unclear how much impact this will have on the overall environment today. It looks like the best environment is going to be a little bit farther to the south, displaced from the track of this MCV, which is heading into Pennsylvania and eventually New York. But out ahead of this, we could see a little bit of an increase in severe storm coverage, given a little bit of help, a little bit of extra forcing from this MCV. We'll talk about that a little bit more in just a second. But overall, we had a line of severe storms moving through Illinois yesterday that produced some tornadoes and other severe weather. That has since dissipated. It was expected to last through much of the morning today, but it has dissipated, and we don't see much of that remaining. A few storms here in northern West Virginia shouldn't be an issue. They should move on out. And we should have a pretty untapped environment here come late morning for the initiation of storms in this environment. We'll go down to the south just a little bit and show you what's going on in the southern regime here. This is a cluster and line, couple of clusters/lines of severe storms here moving through Oklahoma into Arkansas. fostered by warm advection and that secondary speed max there. These will continue to move off to the southeast as we go through the next couple of hours, probably dissipate through the morning. But there is an unstable environment already in place across this area, so we could see the maintenance and re-intensification of this band of storms going into the afternoon, along with some new development here as those storms move into the southeast states. Visible satellite here, and you can see that swirl in the flow centered across eastern Ohio. It's not quite as notable as it is on radar, but you do see a little bit of a swirl in the flow there. That is that MCV associated with that decaying convection. Going to again move off to the east-northeast over the next several hours into Pennsylvania, far southern New York. There is quite a bit of clearing up here. That was the question with the northern portion of this setup. They had the enhanced risk down here, really in southern Pennsylvania yesterday. Now they have moved it up into northern Pennsylvania, northeast Pennsylvania, and far southern New York. I think because we have this MCV there, and because we have a little bit more clearing than maybe what was expected. Still quite a bit of cloud cover entrenched across this region and moving in from the west associated with this MCV. So that is going to have to be something to watch over the next several hours for at least the northern portion of the risk area. But we do have quite a bit of clearing moving in right now, and especially with southern extent. Southern Pennsylvania, West Virginia, into Kentucky, Tennessee, and the Carolinas, and Virginia. Quite a bit of clearing moving in, so we shouldn't have a problem heating that surface, getting that instability to build by what appears to be an early initiation for storms today. We'll show you some data here in a second to show why that will be the case. So all in all, a nice looking environment already. Just looking at the satellite for today, let's look at some upper air maps right now. And this is our 12Z 500 millibar map. It's our most recent 500 millibar map. I'm going to refresh it here just to make sure it's up to date. And it is. So this is 12Z 500 millibar map. And here is our big old trough. Big old trough centered here across the southern Great Lakes. And over the last several days, as we talked about, this has taken on more, it was initially more of a positively tilted trough and is now starting to wind up a little bit more and become much more of a neutrally to slight, it's still probably slightly positively tilted, but as we go through the day today, it will take on a more neutral to slightly even negative tilt to this trough. And the tilt of the trough doesn't matter so much for severe weather, but oftentimes with these big severe weather events, you'll see a more negative tilt to the trough. Just means it's more wound up. It has a little bit more favorable ingredients associated with it aloft to initiate more robust severe weather. You can still get plenty of severe weather with positively tilted troughs, but that can help it can help your environment become a little bit less robust in terms of the wind profile and how it can maintain severe or discrete supercells, and the overall progression of the environment can be not quite as favorable for significant severe weather as when you have a negatively tilted trough. But overall, it doesn't matter all that much, but this trough is taking on a little bit more of a negative tilt as we go through the day today. This little jet streak, 50, 60 knots, even 70 knots of flow there right at the center of the jet streak there. That will continue to move off to the east-northeast and take aim at that mid-Atlantic corridor here today. Secondary speed max back in here will take shape as we go into the next several hours. You can't really see it right now, but let me go forward here and we'll take a look at more model data in a second. But you can see the separation of those two speed maxima, those areas of blue shading. It's the area of stronger winds back across Oklahoma and Arkansas, pointing right into the southeast later today, and then your secondary area associated with the main trough up into the mid-Atlantic. And this is valid at 19Z, so that would be 2 p.m. Central Daylight Time, 3 p.m. Eastern Time today. But that is how our trough looks today. Very nice defined exit region, a nice defluence aloft. If we were to go up to 300 millibars here, that defluence aloft, you'll see very nice here. That defluence aloft is the spreading apart of those wind vectors aloft. And we've talked about this before. That acts as a vacuum cleaner kind of effect and enhances the lift where you have stronger defluence aloft. It acts to create a void in the atmosphere, those winds spreading apart from each other. The atmosphere doesn't like that, so it tries to bring air up from below to fill that void. That's how you get lifting, favorable lifting for severe storms in a given environment. We have some nice defluence here in the exit region of this trough today, and that exit region will translate off to the east over the next several hours. Now, notice the position of the trough here and the position of our moderate risk. So you can see that trough is already starting to eject into this mid-Atlantic region. That's why we're going to have an earlier initiation of storms today. Probably really, by the time you're watching this, we should have storms that are developing across this region, maybe even as early as 10 a.m. or so, out across far southeast Ohio, eastern Kentucky, into the West Virginia area initially, right in the exit region of this trough, which is almost already over that area. So, and we already have a robust environment in place. We'll take a look at some sounding data in a second to support early development of severe storms. But that is how our trough looks in the upper levels of the atmosphere. Now that we have a stronger trough, the last couple days we haven't really had the favorable orientation and setup for this trough to promote a really strong low-level response. Well, that has changed. And let me go down to 850 millibars here, and you see a much stronger low-level jet associated with this low-level cyclone here, centered up in the Great Lakes region. Nice lobe of 35 to 40 knots of flow across all the way down from Arkansas up to the northeast into Kentucky, Ohio, West Virginia, far southwest Pennsylvania. This will continue to translate to the northeast today and overspread the region, and will likely enhance that low-level flow and provide a little bit of curvature to those photographs. Although the flow here at 850 millibars is pretty significantly backed. That's not quite that unusual for severe weather events here in the mid-Atlantic. We often have veered low-level flow, but I don't think it's going to be too much of an issue. Sometimes when you have extremely veered low-level flow, you'll have drier air out here to the southwest, which is brought in to the low levels by this southwesterly low-level jet, and can have some negative impacts on the environment and negate the overall threat for severe weather. Not the case today. I think we have a very widespread area of low-level moisture out across this region. So even though we have very much veered low-level flow, it should, number one, help to increase those photographs in the low levels just a little bit as far as curvature goes for a tornado threat, as well as keep that low-level moisture flowing in rather than flow in quite a bit of dry air into this region. So, nice low-level jet out across this region. Of course, will translate to the northeast going into the late morning into the afternoon as this low meanders off to the northeast very slowly. Down at the surface, you'll see the reflection of the surface low here, right just to the east of Michigan there in southeast Canada. Does extend farther, kind of a banana-shaped low here down to the south. Cold front likely situated back somewhere in here. And we do have a little bit of a surface trough out ahead. We'll take a look here at the surface data real quick to see if that is the cold front. It's a little tough to tell where exactly that cold front is. We do have northerly flow back here across Missouri and Iowa, much more westerly flow here across the surface. So it appears that the actual cold front probably is going to be somewhere in this vicinity right in here. Not too much of a temperature gradient to speak of, but we do have quite a bit of a wind shift here. Illinois, there are central Illinois winds out of the north, with winds more out of the west-southwest here across southern Illinois, with a bit of a gradient in temperature. That's probably where your cold front is located. Now, so that would be expected to be within that surface trough there. So we do have a bit of a surface trough. There's probably your cold front right in there. Now we do have a little bit of a secondary surface trough out ahead of this cold front. That is going to be ahead prefrontal, and that likely will be the first initiating mechanism for severe storms out across the mid-Atlantic states. Southeast Ohio into West Virginia, eastern Kentucky by mid to late morning here as the surface trough moves east. You see the kink in the isobars here out ahead of the main cold front, which does appear to be probably back in this region right there. This little surface trough will be a nice forcing, will provide some nice forcing for severe weather that is out ahead of the main cold front and will be probably our main surface influence for initiating severe weather in this environment as it moves off to the east. So nice surface trough there, prefrontal surface trough. And we've talked about prefrontal troughs before. That can help produce a little bit more discrete storm activity. We talk about it often in our southeast events. When you have a prefrontal trough, it can provide a little bit more subtle forcing than your main surface boundaries, i.e. the cold front, and can help keep storms a little bit more discrete early on. That may or may not be the case today. We may have a little bit shorter of a window for discrete storms. We'll talk about that as we look at some model data here in just a second. Surface low should meander off slowly to the northeast today, and eventually that cold front will swing through. The surface trough moves east, cold front will swing through eventually, and allow for an eventual transition to more of a linear mode out here across the mid-Atlantic. Back to our surface data here. So we'll take a look. Here is our surface low centered up here in far eastern Michigan up into southeast Canada there. Cold front extends back down to the southwest, probably somewhere in here. Little tricky to decipher right there. In our surface trough, you see that little bit extra, sort of a convergence zone here out across maybe southern Indiana into western Kentucky. Those winds in southern Indiana out of the west-southwest. A lot more southerly to south-southwesterly flow here across Kentucky down into Tennessee. So that tells me there's some sort of convergence area in there. And if we were to draw in our isobars there, we would see a little bit of curvature there in the isobar. So there definitely is some sort of convergence zone slash prefrontal trough out ahead of the cold front. That is going to move off to the east and be our main initiating mechanism for severe storms, at least early on in the Ohio, West Virginia, Kentucky vicinity. Now, as far as our environment goes, very juicy air mass here at the surface, 70s, upper 60s to 70s dew points all the way up to the Great Lakes, Ohio down into the south. So a widespread area of strong low-level moisture there out across this region that extends up into the atmosphere. That's why we're not, even though we have somewhat veered low-level winds here at the surface and up to about 850 millibars, we're not going to see any dry air sneak its way in. That would be more of a problem if we were in, say, Texas and we had this much more veered low-level profile. You'd see a lot of that dry air from West Texas into western Mexico being ushered into this area, dry out the low levels, and overall be a negative impact as far as severe weather goes on the environment. Here, not the case. We're still going to be drawing very moist air into this region. And this is a pretty common setup, as we talked about, this more veered low-level flow. This is a hodograph cheat sheet from Cameron Nixon that he put out quite a while ago, showing some pretty common hodographs in different places of the U.S. And you see down here in the bottom right corner, this is our southeast / mid-Atlantic bullet type setup. So this is our most common severe weather type hodograph for mid-Atlantic severe weather events. And you can see that low-level flow there, that the end of the pink into the red region, definitely is much more veered than it would be in, say, the plains, where you'd have usually a more southerly to southeasterly low-level jet, for example, here panhandling in Kansasing, much more backed low-level flow. But this is not uncommon for this region, the mid-Atlantic, to have more veered low-level flow in their severe events out there. So not all that unusual to have veered low-level flow, and it doesn't look like it will be a negative impact on the overall severe threats in this region today. All right, let's look at some sounding data here. This is the Nashville, Tennessee sounding, so northern Tennessee at 12Z, so 7 a.m. Central Daylight Time here, 8 a.m. Eastern Time. And you already see that we have quite a volatile environment in place. Already almost 2,000 joules per kilogram of mixed layer CAPE here, thanks to some steep lapse rates aloft, 6-7 plus lapse rates aloft. Nice moist profile here, 73 over 72 at the surface. Fairly moist air that extends well up into the atmosphere. And as such, we have quite a bit of instability already in place. Even at 7 a.m., 2,000 joules per kilogram at 7 a.m. Central Time is quite the environment to have already in place, and that is only going to increase as we go into the late morning and afternoon hours as we get that sunshine to keep moving its way into the region. We get some cooling aloft from the approach of the upper trough. This environment will also continue to advect to the northeast into the mid-Atlantic states, West Virginia, Pennsylvania, Virginia, that region as well. So this is the environment we're going to be looking at later on today. You see that veered low-level flow already. Surface winds fairly weak, fairly weak out of the south with some veered low-level flow. Not much curvature to speak of in the low levels, but there should be enough here come the advance of that low-level jet into this region to allow for some curvature in those hodographs, and we should see a threat for tornadoes develop with these storms. Already, we do have 300 meters square per second square of effective storm relative helicity in place here across northern Tennessee that will advect northward. It's not that classic meat hook looking hodograph that you'd like to see you often see in your more plains type tornado events, but we do have enough curvature there in the low levels and enough speed shear as well to create a tornado threat with these storms. That's, I think, one of the reasons they haven't gone a significant tornado with these outlooks. They only have a 10% unhatched area think it's because we have a little bit more veered low-level profile, a little bit more unidirectional profile. We do have a little bit of veering in those low-level winds with height, but overall, fairly unidirectional profile here. You see mostly westerly winds, except for that surface wind barb there, and a very, very, very unidirectional profile as we go up into the atmosphere. Not much change at all in the direction of the winds going up into the atmosphere. We do have some speed shear, increasing from the low levels, 850 millibars, about 25 knots, to 300 millibars, about 50 knots here. So we do have speed shear, but not much directional shear. And these type of environments, that tends to produce more of your damaging wind type environments than a tornado environment. And you can see by the hodograph, much straighter of a hodograph, but we do have enough curvature there in the low levels, I think, for somewhat of a tornado threat with these storms, given robust instability in the deep layer and in the low levels here. So we go to the northeast. This is Wilmington, Ohio. A little bit of influence, I think, maybe from the morning convection and storms. Not much instability up here. We'll take eastern Pennsylvania here, or western Pennsylvania here is Pittsburgh. And you'll see that some instability already in place, about 1,000 joules per kilogram of mixed layer CAPE, with very strong low-level instability there. 0 to 3 kilometer CAPE already at 128 knots. So we should have a decent amount of low-level instability as well begin to build, especially as the low levels warm from surface heating. And we have some cooling aloft from the approaching trough. So that is what's going on right now. Again, that environment in, I think, northern Tennessee is going to be a nice proxy for what is going to be seen in the environment as it is advected to the northeast out ahead of the approaching trough over the next few hours. This is a little bit of curvature there in the low levels with a strong instability. That is a more unidirectional profile. That is a classic setup for initial semi-discrete supercells and clusters developing into a squall line with significant severe wind gusts. All right, let's dive into some model data now. This is the 12Z NAM that is rolling in right as we speak. It just started coming in. We do have a few hours out here toward 0Z today that should give us enough of a clue of what is going to happen with the progression of this system. So here is our initialization. This is at 500 millibars, starting at 12Z. You can see the big old trough there across the southern Great Lakes into the Midwest. First lead speed maximum out here from Missouri into southern Illinois, southern Indiana, western Kentucky and Tennessee. Secondary speed max back in here across the Kansas-Oklahoma border region right now. Again, this initial one going to be moving off to the east-northeast today. This second one moving off to the east or east-southeast today, focusing on the southeastern portion of the risk area. And you'll see that very clearly as we go into the next several hours. That initial speed max separates from the trailing speed max, and we should have basically two separate areas of severe weather potential or severe weather development going into the afternoon hours today. Now, once again, you'll see how the progression of this trough has happened. Much more of a positive tilt. Even here at 12Z, you'll see the speed max is situated back here to a little bit on the southwestern flank of the main area of curvature with this trough. So much more of a positively tilted trough right now. And it's not going to take very long for this thing to become much more neutrally to even negatively tilted. This is 18Z, only 6 hours from now, or 6 hours from when this was initialized. We have a much more neutrally to still maybe slightly positively tilted than my 21 to 0Z, much more neutrally to slightly even negatively tilted trough moving into the East Coast. You can see a little bit of a shortwave here on the backside associated with that trailing jet max moving into the southeast. Again, that's why we should have maybe a slightly separate area of convective development here in the southern portion of the risk area. So interesting progression with this trough, definitely a strongly forced system here, not something you see in the springtime with 90, 100 knots, 120 knots of flow here at 500 millibars across the plains, but for the summertime, this is definitely an unseasonably strong belt of flow associated with this shortwave trough moving into the mid-Atlantic. Okay, we'll zoom in and head down to the surface now. So you have the surface pattern progresses. This is how it's been initialized. Low across the main surface low up in southern Ontario. Cold front extending back down to the southwest, well back into southern Illinois, with that prefrontal surface trough out across southern Indiana into Kentucky and Tennessee. This, again, is going to move off to the east and will be our main initiating mechanism for severe weather as early as mid to late morning. This is at 15Z 10 a.m. You see our surface trough is somewhere in here. Moved fairly quickly into eastern Kentucky, central Tennessee. And with that environment we saw at the Nashville sounding, advecting quickly into this region, and the exit region of the trough impinging into this area as well. we're going to see an early start to the storm. You see the forcing, the head of the jet max is already here, overlapping that surface trough, which is why we're going to see that forcing overspread the region, and initiation of storms will be very, very early in this region, given an already volatile environment out across this area. That forcing will arrive probably by about 10 a.m. or so out across this region, which is when we should see storms initiating across eastern Kentucky, southeastern Ohio, maybe southwestern West Virginia, far western Virginia, and then into far northeast Tennessee as well. So then we'll go back to the surface here and see how that progresses. So this is at 15Z, 10 a.m. Central Daylight Time, or 11 a.m. Eastern Time. This is 3 hours later, 2 p.m. Eastern Time here. And you see these surface trough has moved off to the east even more, slanted a little bit to from southwest to northeast, and that may have an impact on the overall storm mode and the transition to a linear mode. Let's just do that right now. So this is our surface trough. So that will be our initiating, not really an initiating boundary, but slight convergence zone along that, so we can call it an initiating boundary. So, and then let's look at our shear vectors with respect to that initiating boundary. So that dashed line is our surface trough, and here are our shear vectors with respect to that initiating boundary. There's a decent component off of the boundary there, off of the surface trough. So I think we will have a window for discrete storms out here, out across, at least in the first couple of hours of the convective life cycle. Then we have that trough start to move in, the main forcing moves in, we'll have a lot of storms in a very, very unstable environment, so we could have a lot of storms in close proximity to one another, and therefore we will probably see a somewhat rapid transition to a more linear organization to the storms. Here we are 3 hours later. We still maintain a nice perpendicularity with the initiating boundary as far as those shear vectors go, but I do think we will have a lot of storms in this very highly forced environment. So I think we will transition to more of a squall line eventually, especially as we move into central Virginia, up into eastern West Virginia, central North Carolina, and areas to the east of there. I think we will see a fairly quick transition to a linear organization of the storms, maybe a 3.5 hour window or so for semi-discrete storms and clusters out here across the initiating areas, southeast Ohio, eastern Kentucky, southwest West Virginia, into western Virginia. But eventually, I think things will, given these very strong forcing aloft, will transition to more of a linear complex. And also the fairly unidirectional wind profiles as you go up into the atmosphere. I'll show you those once again for our Nashville sounding. Not much change in the direction of the winds as you go up into the atmosphere. There is some change in speed, so more so driven by speed shear. These events tend to be a little bit more linear in nature, so that is also a factor contributing to more of a linear mode with time as these storms progress to the east. So we'll go back to the surface here and show you this is at 21Z, so 5 p.m. Eastern Time. This is 0Z, 8 p.m. Eastern Time. You'll see that the trough has progressed all the way to the east coast now, so we should have a nice squall line at this point, extending all the way up from Pennsylvania, southern New York, down into Virginia, the Carolinas, out to the southwest, into the southeast states, driven by that secondary speed maximum moving in. Much more veered flow out here, so the tornado threat with southwest extent will be much, much less. But there will be still a damaging wind threat down here as well, as storms will congeal into a line and produce some significant damaging gusts, given very strong instability in place. Steep lapse rates, strong instability in the low levels will help really transition those wind gusts from aloft down to the surface. And as those storms congeal, we will see conglomerating outflows for a significant severe wind threat. Moisture, once again, not an issue today. We will have widespread 60s and 70s dew points across much of the region. The 70s dew points are the purple colors here. Your blues are your upper 60s dew points. So not going to have to worry about moisture today at all, which is not uncommon for this time of year. It's summer. Most of the U.S. is struggling with that real deep, very humid conditions at the surface because of that summertime moisture in place and those hot temperatures. So lots of moisture in place for today. Not going to be an issue moisture-wise in this environment. Now let's take a couple of, at first let's go to the 850 millibar map, show you that low-level jet, how it progresses throughout the day. Nice plume of low-level jet moving into the East Coast. It's not a 60, 70 knot low-level jet you'd see in the plains, perhaps. A little bit stronger to the north. You see a little bit more of that plume of low-level jet remains out across Pennsylvania and New York, but once again, That is going to be an area that we're going to have to watch. It's unclear how much instability is going to build into that region. If we do get a little bit more instability, a little bit more clearing to maintain itself across this region, wind profiles will be a little bit stronger, closer to the surface low center up here in southern Ontario. A little bit stronger low-level jet, perhaps a little bit more backed low-level flow. Let's see the surface map up in here. You see, especially up in here, your warm front extends up in here into New York. If we can get enough instability up in here, that would have some pretty interesting photographs, I would suspect, up in here as well. And we'll look at some soundings now, given a little bit more backed low-level flow, a little bit more veering of those low-level winds with height. It all depends on instability, though. You see up here very, very skinny instability with northern extent here. This is from south central New York. But those photographs looking pretty good. Deep layer shear on the weaker side because we're farther removed from the overall main jet max and the main strong winds aloft. But that low-level curvature is pretty noticeable there. Lots of veering in those low-level winds with height. Instability much more on the weaker side, though. Does have decent low-level instability, 0 to 3 kilometer Cape at 166. With about 1,000 joules per kilogram of Cape, but it is on the skinny side. So we'll have to watch that northern areas of the risk, or northern portions of the risk area up into central to northern Pennsylvania, southern New York, southern to central New York. We'll have to watch that. If we can get more destabilization up there, there will be a severe threat, perhaps more of a supercell threat up there, given a little bit stronger low-level shear, despite marginal deep layer shear. Now let's go south here. We'll go back to about 15Z. We'll go see the progression of these forecast soundings with time. We'll start off at the Kentucky, West Virginia, Ohio triple point there, and this is at 15Z, so 10 a.m. Central Daylight Time, 11 a.m. Eastern Time. Robust instability. You see, this looks very much like our 12Z observed Nashville sounding. Robust instability in place, 2,200 joules per kilogram of mixed layer Cape. Strong low-level instability, over 120 joules per kilogram of 0 to 3 kilometer Cape. Very deep moist layer there. So once again, moisture not going to be an issue today. And our photographs, definitely not eye-opening as far as a significant tornado threat, which is once again why I think they've held back going with a hatched area for significant tornadoes. We do have, I think, just enough curvature, despite a very unidirectional wind profile for the most part, to foster a few tornadoes with the early activity as it maintains a more supercellular, more semi-discrete configuration. Deep layer shear, 35 knots. That should increase with time as the trough moves in. So this is going to be at 18Z now. We'll take it from the same area. See if it's convectively contaminated. This is getting close to that surface trough. We'll see if it's convectively contaminated. And you see with time, the low-level winds, as you stay at one point, with time, those low-level winds are going to continue to veer. As the cold front, as the surface trough moves through and moves past the area, those low-level winds are going to veer. And those low-level photographs are going to straighten out quite a bit, as you see here. Let's go off a little bit to the east, maybe. We'll go into eastern West Virginia here at 18Z, so 2 p.m. Eastern time. And you'll see we still maintain that curvature there as we move, those storms move to the east. A little bit of curvature, very similar to our mid-Atlantic bullet that we looked at from Cameron Nixon. Not a ton of curvature there in the low levels, but a very strong low-level flow, leading to just enough low-level curvature amid adequate deep layer shear for supercells, just enough veering in those low-level winds to maintain a tornado threat across this area. But once again, damaging winds going to be the main threat, given strong flow aloft, transported, those wind gusts going to be easily transported down to the surface, given strong low-level lapse rates and low-level instability, and a transition eventually to a more linear storm mode. Decent instability, 1,600 joules per kilogram of mixed layer Cape. With that photograph, that is definitely a supercell wind profile, and depending on how long supercells stay semi-discrete for, we will see a continued tornado threat with these storms, and even as they congeal into a squall line, they will maintain a tornado threat, given just enough curvature in the low-level flow. 21Z, Northern Virginia here. We'll take a sounding from there. And just to show you the environment down to the south, we'll take a sounding out here in northern Georgia, just to show you that the environment is not quite as favorable for significant severe weather, at least tornadic activity down there. This is a nice looking sounding at 21Z here from Northern Virginia. Nice backing of the low-level flow here, according to the NAM. So a little bit more curvature here in the low levels of the photograph, 240 meters square per second squared effective storm relative helicity, 87/74, very juicy low-level environment, very unstable environment, 2,700 joules per kilogram of mixed layer CAPE. This is definitely a significant severe weather type of sounding with the deep layer shear favorable for supercells and a continuation of the severe threat well to the east. Storm mode is, of course, the fly in the ointment, but very steep lapse rates aloft, strong instability with this strong low-level shear does create a tornado threat with these storms. We could see a significant tornado or two, but I don't think it's going to be a widespread enough significant tornado threat to foster the inclusion of a hatched area on the upcoming SPC outlooks. Here down to the south, you see the hodographs not quite as favorable. Deep layer shear not quite as strong. Instability very, very strong, 3,800 joules per kilogram mixed layer CAPE, but your hodographs definitely not as favorable for tornadic activity, more so a damaging wind threat down into the southeast states into the afternoon. So we continue on through the evening, and that should be, we should have a squall line, full-on squall line by this point as storms move toward the Washington, D.C. area later this evening, eastern Virginia, eastern North Carolina, and down to the southwest there. We should have a full-on squall line as the forcing increases and as those storms congeal, outflows congeal into more of a squall line. Let's go ahead and show some model data here, some convective allowing model data. This is the 12Z HRRR. And again, take these with a grain of salt, but these can give us a nice estimate of what the radar might look like later on in the day. So 12Z HRRR, you see a couple of scattered storms here out across the Illinois to Pennsylvania corridor there this morning as it was initialized. And then you see very early on, this is at 15Z, so 10 a.m. Central Time, 11 a.m. Eastern Time, we start to see a lot of storm development here at that Kentucky, West Virginia, Ohio triple point area. This is, again, very, very early on because we have that volatile environment in place already, and this is the time at which the forcing finally arrives, and it's going to be sometime in the mid to late morning hours. So this is by noon Eastern, 1 Eastern. We start to see some semi-discrete updrafts within this cluster, and things start to get a little bit more robust here. And we should have a few semi-discrete supercells and clusters here with that all hazards threat, at least initially. And then you see very quickly we start to see the squall lines start to fill in. So much more of a threat for damaging winds going on into the mid-afternoon hours. This is at 20Z, so 4 p.m. Eastern Time. Some semi-discrete updrafts still remain within this line. We could see a few storms out ahead of the main line as well. You see up here into Pennsylvania, a couple of semi-discrete supercells up in there across Pennsylvania. And so anything out ahead of the line will have an enhanced tornado threat with it. But by this time, by mid-afternoon or so, we should see more of a solid line start to develop, and then eventually a pretty potent squall line makes its way out to the east, places like Baltimore, Washington, D.C., eastern Virginia, and down into the southeast, a very potent squall line with significant damaging wind gusts possible for some of these major population centers. And then eventually going into the late evening hours, that squall line makes its way into the Atlantic Ocean. Let's go down to see what other models we have going on here. Let's take a look at the NSSL WRF model. A couple of our cams rolling in now. So you see, once again, very, very early start. This is at 10 a.m. Central Time, 11 a.m. Eastern. This is at noon Eastern. There's a couple of semi-discrete supercells there across eastern Kentucky, northeast Tennessee, and perhaps up into far western West Virginia. It'll just depend on how long these storms can stay semi-discrete for the tornado threat. You see much more of a clustered type mode start to take shape by early afternoon, and then eventually a squall line. Interestingly enough, the NSSL WRF is showing a couple of semi-discrete updrafts out ahead of the main squall line here across Maryland into Pennsylvania. So we'll have to watch that. Again, any semi-discrete supercells out ahead of the main line will have an enhanced tornado threat in this environment before the line catches up and we have more of a full squall line with a damaging wind potential, significant damaging wind potential into the East Coast. One more model here, FV3, or maybe a couple more. We'll look at the FV3 and the RRFS. So FV3 here, lots of convection here, eastern Kentucky by midday or so, late morning to midday or so, and then we will see more of a squall line here. A couple of supercells out ahead of the main line. Most of these models are highlighting more of a semi-discrete mode out here ahead of the main line here across Maryland into Pennsylvania. So we'll have to watch that. Lots of model consistency in that solution. Perhaps a couple down here as well. We'll have to watch that as we go into the early afternoon, and then eventually the squall line takes over as outflows congeal. RRFS, this is from the 9Z Rufus model. And you'll see very early on storms fire a little bit farther west than the other models, but the idea is the same. Southern Ohio into eastern Kentucky, northeast Tennessee is where our initial storms will fire along the surface trough as the forcing moves in. Semi-discrete for a few hours before things take off into more of a squall line going into the mid-afternoon hours. You see up here, we do have activity on some of these models up into New York and Pennsylvania. Again, we'll have to watch how the clearing develops and how much instability develops into those areas. But with a little bit more of a curvature in the hodograph throughout the duration of the event, we could see a few more instances of tornadic activity up there pending sufficient destabilization. So all in all, a very interesting setup for today for the middle of summer. Not something you see very often. A moderate risk, level 4 out of 5 once again for the southern and central Appalachians into the mid-Atlantic and East Coast states. We'll zoom in here, show you who's in and who's out. So Western Virginia, places like Richmond, Roanoke, into West Virginia, the eastern half of West Virginia, up into the Maryland and southern Pennsylvania area. So Baltimore, Washington, D.C., well within the moderate risk today. The moderate risk is driven by severe wind gusts. You see a 45% hatched area for significant severe wind gusts out across that moderate risk area. So damaging winds are certainly a concern today out across these major population centers, and also a tornado threat. Tornado threat is at 10%. Whether or not they'll upgrade to a 10 hatched, I don't think that's in the cards for significant tornadoes, but we'll have to see. There could be a significant tornado or two given very strong instability here, especially in the low levels. With decent low-level shear, strong instability can make up for a lack of low-level shear at times, but I don't think they will go 10 hatched across this region. But nonetheless, the tornado threat is elevated across this area today, 10% unhatched area with a large 2% and 5% areas extending all the way up into the Canada, New York border region, all the way down into the southern states. Large hail threat as well, given strong instability and initially somewhat weak low-level shear, but I don't think large hail is going to be the main threat today. It will be tornadoes and damaging winds with these storms. And again, your moderate risk area is that area in red, surrounded by a very large slight and enhanced risk extending all the way up from the U.S.-Canada border in New York down into the southeast states, Alabama, Georgia, South Carolina. Once again, there is that slight risk out to the west across Colorado, Kansas, and Nebraska for the threat for supercells with all hazards, including a tornado threat 5%, damaging winds, and large to significant hail across that region. But again, our main focus is on this moderate risk level 4 out of 5 out across the mid-Atlantic states. So if you're in these areas, places like Baltimore, Washington, D.C., Richmond, Virginia, definitely keep a weather radio handy today. Keep your eye on the sky, as we will get an early start with these storms. Definitely by mid to late morning or so, storms will start to intensify. First across the southern Ohio, West Virginia, into eastern Kentucky, northern Tennessee vicinity before increasing in coverage and intensity as they move off to the east. Places like Pittsburgh and areas east up toward the Binghamton, New York, and Scranton, Pennsylvania areas in the enhanced risk. Pending sufficient destabilization, we could see a tornado threat and damaging wind threat develop up there. But again, the main threat is going to be with those initial storms that will increase in coverage and intensity moving off to the east into that moderate risk area, including places like Baltimore and Washington, D.C. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.